The bleed air system receives air from three sources: the engines, the APU, and ground pneumatic sources. Bleed air from the engines, APU, and ground sources is supplied to using systems through bleed air ducts. The following components and systems use bleed air: air conditioning packs and pressurization, air-driven hydraulic pumps, aft cargo heating, cargo smoke detection, hydraulic reservoir pressurization, wing and engine anti-ice, potable water pressurization, engine starting, and leading-edge flaps. Controls for the bleed air system are located on the overhead panel. The left and right isolation, or left ISLN and right ISLN valve switches control valves that isolate the bleed air duct into three sections. These switches are on during normal operations. Position the left and right bleed isolation switches to on. Continue. The engine bleed air switches and system logic control the engine bleed air. These switches are on during normal operations. The APU bleed air switch and system logic control APU bleed air. This switch is on during normal operations. Bleed air from the APU is used primarily on the ground for air conditioning and engine starting. However, bleed air from the APU may also be used in flight up to an altitude of approximately 15,000 feet. Let's use the ECS synoptic to see how the system works. Display the ECS synoptic. The APU bleed air switch is normally left in the on position. Select the APU bleed air switch to on. Positioning the APU bleed air switch to on with the APU running causes the APU bleed valve to open. Duct pressure indicators on the synoptic indicate pressure in the ducts. Bleed air is now available for the air conditioning packs and for starting the engines. Let's discuss engine bleed air operation. Bleed air normally comes from the engine intermediate pressure or IP section. Air from this section is used primarily during high thrust settings such as takeoff, climb, and cruise. Bleed air also comes from the high pressure or HP section. Air from this section is used to supplement low pressure air during low thrust settings such as during descents. The pressure regulating valve, or PRV, limits bleed air pressure and temperature in the ducts. Watch what happens as the system responds to an increase in bleed air temperature. Normally, the engine bleed air switches are left in the on position. Push all 4 engine bleed air switches to on. Continue. 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 Notice the off lights remain illuminated. The engine bleed air valve remains closed to prevent reverse flow when bleed air pressure from another source, for example the APU, is higher than bleed air from the engine. However, during engine start, the bleed air valve opens to allow reverse flow from the bleed air duct, and the pressure regulating valve is commanded positively closed to prevent reverse flow into the engine compressor sections. Now watch the engine bleed air indications as the number 4 engine is started. All packs may be off, or one pack may be on for engine start. For this example, set number 2 and number 3 pack control selectors off. Continue. Start the number 4 engine. The engine bleed air valve opens when the start switch is pulled. After 50% N2, the start valve closes, which enables the PRV to open and the engine to supply bleed air. A check valve in the APU bleed duct prevents reverse flow into the APU. Let's look at bleed air non-normal operations, beginning with bleed leak detection and isolation. The bleed leak detection system protects bleed air ducts throughout the airplane. The protected areas include the left duct section, the center duct section, and the right duct section. Now, here is an example of a bleed duct leak, isolation, and resulting system losses. The ICAS caution message, Bleed Duct Leak Center, is displayed. Accomplishing the Bleed Duct Leak Center checklist isolates the leak. Notice the isolation procedure has shut off bleed air supply to several systems, including Pack 2, trim air, cargo smoke detection, and aft and bulk cargo heating. In this configuration, cross-bleed start capability and APU bleed air are not available. The ICAS message Bleed Isolation or Bleed Isolation APU indicates disagreement between the commanded position and the valve position. The valve may be closed when commanded open, or it may be open when commanded closed. Let's look at some engine bleed air non-normal conditions. The ICAS advisory message bleed is displayed when a bleed air overpressure condition is detected, or the high pressure bleed valve has failed to close when commanded, or the pressure regulating valve failed to close when commanded. The ICAS message is accompanied by the engine bleed air system fault light. Depending on which condition caused the bleed message, nacelle anti-ice may not be available, or if available, may not be adequate at low power settings. The ICAS advisory message, bleed high pressure engine, indicates the high pressure bleed valve failed in the closed position. Nacelle anti-ice may not be available at low power settings. No crew action is required. The ICAS advisory message, bleed overheat PRV, is displayed if an engine bleed air over temperature condition is detected, or the respective pressure regulating valve fails in the closed position. The high pressure bleed valve and the pressure regulating valve are both commanded to the closed position, and the engine bleed air system fault light illuminates. Nacelle anti-ice is not available for the affected engine. No crew action is required. The ICAS advisory message, bleed off, indicates the engine bleed air switch is off and the engine bleed air valve is closed with the engine running. Place the number 4 engine bleed switch to the on position.